Good morning, everyone. Thank you so much for joining us in this online international conference on science and technology research, organized by Eurasia Research Association, in order to exchange ideas and share scientific experiences together young and senior researchers. I'm Oumayma Nassiri, PhD student from Cadi Ayyad University in Marrakesh, Morocco. Today, we're going to present an abstract title called Environmental Geochemistry and Ecological Risk Assessment of Heavy Metals in the Vicinity of an Abandoned Lead Mine in Morocco. So, I have divided my topic in the following three main parts. In the first part, I'll present the basic notions of mining activity, its main classifications, as well as the different operations carried out before, during, and after mining, and their environmental effects. At the second part, we would like to present the main result of the present study. The last part is related to our conclusions and recommendations. First of all, we prefer to begin our presentation with definition of mining. What is mining? It's the exploitation of the precious minerals as well as other geological deposits from an ore body as a continuous ore body, dike, seam, lode, vein, or placer, just to name a few, that have potential economic interest to the miner. The art of mining itself comes in many different forms and incorporates many different styles and techniques in obtaining precious resources from the ground. This, as a result, creates a large number of possible trees that have the ability to bring in a balance to an ecosystem. The two main classifications of a mine site are underground and surface as open pit. Underground mining is extracting minerals and ores that are buried too far underground to be mined using surface mining. Here is an example of an active underground mine called Al Hammam, situated at about 10 kilometers from Meknes in the Middle Atlas region of Morocco. This mine is the champion of fluorine, as you can see on the picture on the left above. It's the mineral with the green color. The mine Al Hammam is one of the first mining companies producing fluorine in the world. In the picture below, as you can see, the piles of treatment residue in the form of dunes with the great volume left in situ. The mine in Youssoufia is one of several Moroccan mines owned by the OCP Group, formerly Office Cherifien de Phosphate, located in the central western part of Morocco, considered as the second most important mine to the Moroccan economy and the third biggest producer in the world of phosphate. As you can see in the pictures, the phosphate deposit is more shallow, so surface mining is the best way to extract mineralization, which is covered by soil and generally, any type of ore extraction method follows the same steps and phases. We have in the first place preliminary exploration. In the second place we have infrastructure construction, including ground handling, material handling and pipeline. In the third place we have ore extraction, then crushing and screening that involve the reduction of the particle size in the ore body after extraction, followed by physical separation like magnetic separation or gravity concentration, monitored by milling process, known also as a fine grinding or pulverizing. It reduces material to a powder. Then chemical valorization, known also as ore dressing, it's the process separating valuable minerals from their ore. Then closer mine, and finally mine abandonment. These associated phases produce waste and have the potential to cause serious effect on the surrounding environment. Before, during, and after mining operations, there are many factors that play a contributing role in impacting the environment, as you can see. Mining accidents, health hazard, mine waste damping, noise, subsidence, erosion, flooding, wildlife damage, habitat damage, solid waste, radioactive material, air, water, and soil pollution and heat. The countries that are the biggest miner in the world are, first of all, we have China, United States, Russia, Australia, India, Saudi Arabia, Indonesia, Brazil, South Africa. The strategic metal resources are the manganese, cobalt, chromium, platinum, and finally lead. Morocco today, like all countries of the world, suffers from the legacy of mining activities that are considered a poisonous heritage, sometimes dating back to the antiquity, which is still alive and dynamic, and which, like all human activities, has a dark side from relentless and unmanaged exploitation. As you can see, Morocco is characterized by a lot of mines. Some of them are active, some of them are under development, and others are closed. All those mines are aligned with metallogenic provinces that are associated with the major geodynamic events. Himalaya is one of those metallogenic provinces, named also Lead District, characterized by three abandoned mines, Ahoulim Bleden and Zeta. The present study will focus on the abandoned mine of Zayda with the aim to diagnose the current state of the site, to evaluate the total concentrations of metals in the environment around the mine site, to assess the contamination and potential risk of metals to the environment. The Zayda mine is characterized by more than 7 quarry lake, chemical process equipment left in situ, tree tilling, also an hydrographic network named Mulwiya River and its affluent, located at a few meters from Talens, and this network supply Hassan II Dam mining residue. The total metal concentrations in soil are defined using inductively coupled plasma mass spectrometry for more of 20 samples in the study area. In order to evaluate the contamination intensity of the study area, we used 5 pollution indices, such as the contamination factor, ecological risk factor, enrichment factor, degree of contamination, and geoaccumulation index. The enrichment factor was initially developed to speculate on the origin of elements in the atmosphere and precipitation, but progressively it used to soil and sediment studies. It can be calculated by the following equation as you can see, and it's characterized by 5 classes. As you can notice, the metallic enrichment is accentuated in the terrain and the surrounding soils, while downstream this enrichment decreases. We also notice that all the samples value in the study area are higher than the limit value of this factor. The geoaccumulation index is originally defined by Muller in order to determine metal contamination by comparing current concentration with pre-industrial levels, which are in our study the reference sample value, named also geochemical background of metal. It can be calculated by the following equation, as you can see, and this distinguishes into 7 classes by Muller. As you can see on the figure, the metal that presents risk and an extremely important value is lead. However, the remaining metals are moderately to strongly polluted, while only silver and tin, which does not present a risk in the study area. The contamination factor is used to describe the contamination of a given toxic substance. According to the distribution map of the contamination factor, it can be noticed that the study area is characterized by values higher than the limit value of this factor. Also, we can notice that the residue and soil in the vicinity of them present the highest value, and then this value decreases downstream. The degree of contamination is defined as the sum of all contamination factors. The graph shows the ecological potential as a function of contamination degree. The most distant stations show low contamination, while the rest of the area, including the residue, show high value of these two indices. The ecological risk factor is used to quantitatively express the potential ecological risk of a given contaminant, also suggested by Hickinson. It's used as a diagnostic tool for the purpose of controlling soil pollution by heavy metal. As you can see in the figure, Thailand in the red circle presents a very high ecological risk, while the remaining stations present a moderate to considerable ecological risk. Conclusion and recommendation. The spatial distribution of heavy metal concentrations and numerous pollution indexes in the samples reveal that the higher value are located in and near the mine residue, while downstream this value decreased, which classified the site as very highly polluted and severely contaminated. The result of this work provide a useful database to implement and develop strategy of monitoring and rehabilitation for this area. Thanks for your attention.